I'll quickly record my CHTC run, because I mostly forgot to do this for a while. So first thing we do is in here, you delete this free run. So first thing you do is you have to actually figure out what the layers, what the weights and biases are, so you can actually figure out which ones to freeze. So we run this by running metadata.py. So first we import torch, obviously. You take the pre-trained model, so this is just the path to the model if your local directory. This could probably be done on CHTC as well. It takes in the name of it, blah blah blah. It creates a brand new file called info.txt. It runs through all the info inside of all the things inside of it, and then checks if it's equal to state dict, which contains all of our weights and biases, and then we save that onto the layers info.txt. So I'll quickly run that. I forgot. Alright, so that's irrelevant. So you can see right here. Here are all the layer infos. We have all that information right here, with the biases and all that. So note, there is an extra -n at the end, and I did not bother dealing with that in the code. So get rid of that inside there, so you don't have it. Save it. Bang. So then you move this inside of CHTC, which I'll just assume you did. So this should be inside of the CDVAE main file. So this is where I have it right here. So now we'll go to the metadata fix.py. So metadata fix. This is required because CHTC gives you a brand new working directory every single time you open their thing. So right now I have directory 3722757, right? This would change to something else instead of this one. So and the metadata saves these ones. So you have to change it to the current directory. So this is code that does that. So these are all the things that need to be changed, and then this MP20 has to be edited to your specific data set that you want to manage, and then this goes to the path of it and saves it there. This part doesn't matter. This could be any name. I just had it as this because this was the same name as some of the metadata stuff, and this saves it to the location. This is irrelevant. This is me doing tests. So now that we've gone through all that, we can go do the run. So first we untar the file. I think this is right. So right now we're just running stuff in the SH. So pretty basic stuff. Now that we've run everything, and I don't remember my OnDB code. Don't steal this. Alright, so far we've run this and this. Now we have to run the metadata fix.py, Python metadata fix.py. Alright, this should have hopefully fixed the metadata. Then we go into CD Hydra. We go into our Hydra folder directory. This part doesn't matter. So now we're here. Now we have to make a directory that is of the current date. So for me, it is currently 04/23/2024, but I think it's the 24th for CHTC. So we create one the 24th. So we create one that is 2024-04-24. So you create it based off the date of CHTC, which is typically your current date, but since it's 11:34 p.m., I think it's the next date for CHTC. So we have it here, 2024-04-24. Now we have to go into the pre-trained model, which is right here, and then we have to copy everything here to the others, to the folder that is in the current date. So as you can see right here, you have MP20, and everything should be in there. So now, also, I forgot to mention this. Um, oh, it's C single run. So here, we have two checkpoint files. This is just me being lazy and not removing this. But you could remove this. You don't have to. This will it'll automatically detect this one. But if you want to remove it, you can remove it if you want to. Right now we're here. Then we want to copy all the layers info.txt into that exact same directory we were just in. So we want cp, and we want to throw it into Hydra. That's single run /2024. Throw it in there so that it is in this folder we were just in right here. Right here. Now, after all that, you should be able to regularly run the code. So this is not the code. Where is it? Where's the code? Should be right here. I cannot be asked to do it right myself. So bang. Now it should work. And while this works its magic, I'll go through a little bit of how the freezing actually works. So, go here. Go to how the freezing actually works. Over here. So how I implemented the freezing was, the code specifically has an area that looks for checkpoints and loads them in. So right, go find it real quick. Should be around here. Right here. So right here it says load checkpoint if it exists. So this code basically loads in the checkpoints. This code basically loads in the checkpoint, and by doing that, we would then immediately freeze it after it loads in the checkpoint. So after it loads in the checkpoint, we immediately open the layers info.txt file we put in there, and then layers info.txt file we put in there, right here. It says it right here. We open it right there, and then we immediately set what layers we want to freeze. So over here, it states that I want to freeze the fully connected, the encoder, and anything with fully connected encoder and decoder. So that would translate to these layers right here. You could change it so that it's these layers by running if encoder and decoder in it. But that's if you want to. That's if you want to change it. So then it checks if weights and buys are in the name. So anything with weight and buys, it'll be frozen. It will then split it, and then it runs requires grad at the end. If it doesn't work, it'll print out an error. And if it does work, it should say the set parameter is frozen. So right here, it should be up here that the code says it's frozen. So right here, as you can see all the fully connected layers have been frozen, and all the data backs it, which you should be able to see from my slide deck, which I posted for last week. And then this runs through the data, and after it runs through the train tests and validation data, now it actually run through the epochs until the end of the epoch cycle. So that's basically all you do for the set of code for layer freezing. If there's anything, message me, let me know, etc., and I'll try to upload everything onto a Google file, and I'll save it and share it with everyone.